Hi guys, good evening. Am I audible?
Yes, you're audible.
Okay, Venkat, you have joined previous also, right? Venkat J. Yesterday you didn't join, right?
Yes, yesterday I have missed.
You have missed it. Okay. And Amit Sinha. Amit Sinha, yesterday you have also joined, right? Yeah. Okay. Adi K. You. This is your first class. Adi K. Can you please respond, Adi?
Hello.
Okay. Yeah, Adi. This is your first class.
Yes, sir. This is my first class, sir.
Okay.
I have seen
So,
in the Durga Soft portal. Today only I have seen Durga Soft portal and immediately I have joined. That's why this is my first class.
Okay. No problem. So, 1 minute. I want to ask one more time, guys. Amit, sorry for asking this many times. Amit and Venkat and Adi, you three guys are. I mean to say, why I'm asking is just for confirmation. You three guys are continue or not? Can you please confirm me first?
Yes, sir, I'll continue.
Amit, you are continue, right? Okay.
Yes,
See,
sir.
why I am asking you is, Amit, Durgasoft people are trying to reach you, but your mobile is in switched off. Okay. Can you please respond to Durgasoft team? And Venkat,
Yes.
can you? Yeah.
Yeah.
And
I know that.
yeah.
Okay, so
Yeah.
I'll do.
So yeah, Venkat, can you please? Can you please contact to Durgasoft? Okay. Yeah. So Adi K. So this is your first class, right? So
Yes, sir.
definitely, definitely, I will give a backup classes also for you. No problem. Okay. So as of now, I have completed Linux commands and Hadoop commands. Okay. So yesterday I was started this Hadoop architecture. Part 1 is completed, but today I want to explain about mapper phase and reducer phase and all these things. Okay. So if you are continue, I will give the backup classes for you. If you are interested to join tomorrow, I will give the backup classes for you. Okay. So remaining three guys, Amit, Rohit, and Venkat from day 1, they are in these classes. So no, only Venkat yesterday class is he missed it, but no problem. If you can go through the video, then you can easily understand. Okay, no problem. But today I want to continue whenever I so yesterday where exactly I have stopped the class. From that point only, I will start today's class. Okay, no need to worry. No need to worry. Definitely, I will take it back at classes. Okay. So I want to open your class notes. Okay. So yesterday we have seen already the example scenario as well as the Hadoop architecture, 1.x architecture. So again, I want to draw the diagram. So this is your client and this is your master node and these are all slave machines because of Hadoop follows master slave architecture. Hadoop follows master slave architecture. So this is your edge node. What is edge node? That is nothing but your Linux box. So in this, I usually client. Usually your edge node is your client. This is submitted data. So yesterday, this is sample.txt. This is 256 MB data. Okay. So here, master machines. What are the master machines? Name node. This is for storage. For processing, we can use a job tracker. Okay. So here, there is some disturbance from your side. 1 minute. Give me 1 minute. Okay. Okay. Now it is clear. Now the disturbance, it is there any disturbance? Still you are getting any disturbance? Still disturbance? Okay. Cool. So once the data can be, I mean to say name node and job tracker. Name node it is belongs to storage purpose. Job tracker is a master machine for a processing. Name node is for a master machine for a storage. Okay. So now once the data got received, the data can be divided equally, right? This is your next point. How it is divided equally? Because of block size. What is the default block size of Hadoop 1.x? It's a 64 MB. Okay. Hadoop 1.x block size is 64 MB. So your file size is 256 MB. 256 MB divided by 64 MB. How much? It's a total 4 blocks. 256 divided by 64, and it is equal to 4 blocks, right? This is B1, B1, B2, B3, and B4. Okay. So this is a task tracker 1 and data node 1. Like task tracker 2, data node 2. Task tracker it is belongs to processing of a, this is belongs to processing slave machine. Data node is a storage slave machine. Okay. Likewise, task tracker 2, data node 2, task tracker 3, data node 3, task tracker 4, and data node 4. Okay. So here every 10 seconds, whether how much percentage of work it is completed based by using a heartbeat signal from job tracker to, from task tracker to job tracker, we can use a heartbeat signal, right? So that points we need to, first of all, client has provided data to manager. Here manager it is nothing but name node and job tracker. These are the, I mean to say, these are the master machines. Next, manager will distribute the work to team members equally. How it is distributed the work equally? By using block size. Okay. The third point is every 1.3 hour, I mean to say 1.5 hour, manager will send an email to team members and how much percentage of work is completed. So here, based on the heartbeat signal, every 10 seconds. Every 10 seconds, how much work it is completed by B1, B2, B3, B4. It is tracking. Okay. Next, 4 consecutive times a team member is not responding. Manager will not consider the team member, and he will assign that work to another team member based on his or her capabilities. Here also, suppose this data node, it is 4 consecutive times it is not responding from task tracker to job tracker, then this is called it as dead node. This is called it as dead node, right? This is what yesterday we have. So what is this? What is this 10 every 10 seconds, how much percentage of work is completed? What exactly it is? This is called it as we have total 3 phases are available in Hadoop architecture. That is nothing but for processing of data, for map reducing. You can process the data initially at the time of Hadoop introduced into in market. So what is we can use for processing? For processing, we can use a map reduce. In that map reduce programming to process the data, in that map reduce we have total 3 phases are available. What are those phases? Mapper phase, sort and shuffle phase, and a reducer phase. Okay, so here our file name is sample.txt, right? Our file name is sample.txt. In this sample.txt, your data is, hi, this is Pavan. Currently, I am giving Hadoop training in Durga Soft. Hadoop ecosystems are Hive, Pick, Scoop, MapReduce, HBase, etc. Okay, so okay. Now next one. Currently, I am working in one of the leading software company in Hyderabad as a team lead. This is my data. This is my sample.txt file. This data can be placed it into this data Edge node has provided to master machine. So this data, it can be, I'm going to say, divided into 4 blocks. This is B1. This is B2. And this is B3. And this is B4. This is your original data. This data got divided into 4 blocks based on the 64 MB, that is block size. That is also, this is B1, B2, B3, B4. Now I want to process B4. This is for your understanding purpose. I am telling you how we can process the data. This is this line, how to process the data. The same procedure we can follow for the remaining 3 lines also. Okay. Suppose, for example, this line you want to process. What is the first phase? Mapper phase. Before mapper phase started, this data, this entire data can be converted into key comma value pair by using record reader. Okay. By using a record reader, your data is converted into key comma value pairs. That is nothing but in Java, map collection. In Java, we have a collections topic is there. Array, map, set, list, tuple. There are so many concepts are there. In that map, what is the map we use? Map is a yes, Adi. So here it is a key comma value pair. Okay, key comma value pair. So your entire data got converted. Each and every block is converted into, this is comma 1. Okay, this is first one. This is second one, third one, fourth one. Okay. Now I want to process only this line. Whatever the procedure we have we are following for the B4, the same procedure we will follow for the B1, B2, B3 also. Okay. Now this is a input of mapper phase. This is input of mapper phase. Mapper phase input. Okay. This is input, and output should be, you can split this entire line. You can split this entire line based on split based on space. Space is the delimiter. Space is the delimiter. Okay. Either you can use split function or you can use tokenizer, string tokenizer. By using string tokenizer also, you can divide the entire line into number of words. Okay. So your output should be like this. That is, so currently, comma 1, next I comma 1, next am comma 1, next again I comma 1, am comma 1, next working comma 1 and working comma 1, 2 times working and in comma 1, 1 comma 1. Okay. Off comma 1, next the comma 1 and read comma 1, software comma 1. Okay. Leading software company up to this. Okay. Company comma 1. That's it. It's enough. I want to remove this one. Okay. So now it's a time waste. That's it. So now this is input. You can divide this line based on the space delimiter, or you can use a string tokenizer. Okay. So this is your output. This is your mapper output. Now, next phase is sort and shuffle. Next phase is sort and shuffle. In this sort and shuffle, already yesterday we have discussed, you need to write a business logic. You need to write a Java code for mapper phase and reducer phase. No need to write any code or any business logic for sort and shuffle phase. Okay. So Hadoop framework will take care. This phase only Hadoop framework will take care. So what is the input of sort and shuffle? So this is the mapper output. The mapper output should be the input of sort and shuffle input. Say mapper phase output is input for the sort and shuffle. Okay. Now the output is entire thing. Again, I want to copy. How many times it is occurred? 1 and 2. I want to remove this, and here I can add I comma 1 comma 1, because in this line, in the B4 line, I is occurred 2 times. So in the sort and shuffle phase, so the whatever the repeated words are there, for that the output should be I comma 1 comma 1. Am also 2 times it is repeated. So this is, and working also 2 times it is repeated. Remaining all are only 1 time occurred. Okay, only these 3 words. I am working. These 3 words only. For this block 4 only. I'm talking about this only for this block 4. Okay. Now, this is sort and shuffle output. Next phase is reducer phase. For this reducer phase, you need to write a business logic. For this reducer phase, input is output of sort and shuffle. Okay, output of sort and shuffle phase is input for reducer phase. And what is the output? Here we can do the aggregate. What is the meaning of aggregates? Sum. So here we can perform 1 plus 1, 1 plus 1, 1 plus 1. As it is, I want to copy this. And here 1 plus 1, this is 2. Exactly are the aggregations. Here we are using a plus operation. Okay, am also 1 plus 1, 2. So working also 2. This is this mapper phase, sort and shuffle phase, and reducer phase for only for B4. The same thing it will happen for the B1, B2, B3. That is what we are doing here. First of all, mapper phase is initiated. Mapper phase is completed. Sort and shuffle Hadoop framework will taken care. Again, Hadoop sort and shuffle output is input for the reducer phase. Again, it was collected the B1, B2, B3, and B4, and finally it was all the results of B1, B2, B3, B4 also. It was combined and it will give the result. It will give the result. Okay, so this is the way we need to process the data. That is called it as map reduce programming. In that map reduce programming, we need to write a business logic for mapper phase, reducer phase. No need to write a code. No need to write any code for the I mean to say sort and shuffle phase. Now I want to show you. Now I want to show you how to write a map reduce program and how to execute the map reduce program. Okay, how to write a map reduce program, the same program. So whatever the things I have explained here, so how to write a code. Okay, that is I will explain now. So first of all, you want to open this Eclipse. So must and should, you need to write a program in Eclipse only, because of you need to write a code by using Java. For that Java code, where exactly you need to develop, on top of Eclipse. Okay, 1 minute guys, it will take time to open it. Guys, 2 minutes. It is opening.
And so I had one query. How we can access Hadoop? Will we get some sandbox, or by just using Putty we won't be able to connect to Hadoop, right? Or how to configure node, multiple node Hadoop machines in our.
Yeah, okay. Meanwhile, that is we will discuss. Okay. So your question is, so suppose you guys don't have only Cloudera. So how? So in this Cloudera we have a Eclipse. In this Eclipse we need to write a MapReduce program. But suppose you don't have any Cloudera, you have a I mean to say CloudX lab details. CloudX lab details. So how to write this? So what you need to do is, you can in Windows download Eclipse. Okay, write MapReduce program. Okay, and download Hadoop Jars. So how to download Hadoop Jars? Just simple. Google download Hadoop Jars for Eclipse. Okay, these are the Hadoop jars. Okay, one minute. Okay, so these jars, see here, Hadoop jars 1.01 version. See Hadoop download. So here you need to download Hadoop jars. Hadoop jars you need to download, and you can download, once download is completed for your project, you can add all the jar files to your Eclipse. Once you have added all these jar files, Hadoop jar files to your project, then you need to create one jar file. Again, for your project jar file, this Hadoop jars is different, and jar file after adding, once you have done the code is completed, added the Hadoop jars, again you need to create one more jar file. That jar file you can copy by using WinSCP. You can copy from Windows to your CloudX lab. There you need to execute one command. Okay, I will guide you how to do all these things. Okay, no problem. Once this is completed, then you got some idea. After that you can easily do it. Okay,
Okay.
is it clear, Amit?
Yes.
Okay. Okay, now, so I want to create a, 1 minute, guys. Okay, what I need to do is, I want to okay. So I want to create one project, guys. So how to create a project, how to write a code, and how to add a jar files, everything, each and every step I can explain you. First, go to File, New. Here we have a Java project. First, you need to create a Java project. Step by step, each and every step is important. But this is for example purpose only. You no need to prepare this MapReduce programs and everything, because of Nowadays, no one is using MapReduce programming. Just for your understanding purpose, one example I am giving you. Okay. So this is project name. What is your project name? Hadoop word count. Hadoop word count. Okay, this is my project. Okay. Finish. Once it is done, here it was create one project. See, left hand side, one project is created. Hadoop word count. Once your project is created, then you need to, in the src folder, under src folder, you need to create one package, Java package. In that package, all your Java files are all your project related Java files are available. See, package. This package name and your project name should be match. Okay, so done. Finish. So now you can see here package is created. Now under this package, I want to create 3 Java class files. Java class. Okay, class. First one is word count. This is first class. Okay, first Java class is created. Next. So out of mapper, reducer, and sort and shuffle, for how many phases we need to write a code? Mapper phase and reducer phase, right? So next class is word mapper. This is mapper phase. And the last one is reducer phase, because is Java knowledge is mandatory for Hadoop. For map reduce programming, 100% we need Java program Adi, because now you no need to bother about it, because of in none of the companies are using no company, so not even single company is using MapReduce nowadays, because when compared to Spark is 100 times faster than MapReduce. Okay, so in our Spark, I can show you how to learn Scala. Spark with Scala, I will help you to how to write a program and everything. Okay, you no need to bother about that. So next, last one is word reducer. This is word reducer. Okay, done. So total 3 classes I have created. One is mapper and one is reducer. One is word count dot Java. Okay. So now I want to open this word count Java. Where exactly we have written this entire program, MapReduce program. MapReduce program we have written on top of Eclipse. But Eclipse doesn't know what is MapReduce programming. Am I right? Eclipse doesn't know what is MapReduce. So that's why we need to add a few libraries. First, we need to add few. Difference between Spark and Spark, which one mostly? See, Adi, your question is Spark is for processing. MapReduce also processing. MapReduce, by using Java, you can write a MapReduce program. So how to write a Spark code? How to write a Spark code? Spark with Scala, Spark with Java, Spark with Python, Spark with R. Any one of the language you can use to develop a Spark code, but MapReduce programming by Java only. So if you want to develop the Spark code by using Python, that is called it as PySpark. Okay. What is Spark? Spark, it is nothing but, what is the difference between Spark and PySpark is, Spark is a processing engine. Basically, Spark is a processing engine. What is PySpark? PySpark, it is nothing but you can develop a Spark code using Python. That is called it as PySpark. Spark with Scala. You know Spark with Scala. That is nothing but you should develop the Spark code by using Scala. Spark with Java. PySpark. Spark with Python, it is nothing but PySpark. Clear, Adi? Okay. So now I want to add few libraries. What are those libraries? Okay. Libraries are, these are the libraries. Okay. These are the Hadoop related, our program related, word count example related. So what are those? I will explain you guys. No problem. No need to bother about it. Each and every line I will explain. Okay. So here, okay. So first of all, I want to tell you. So whenever you can write a MapReduce program, we need to execute one command. Once your code is completed and everything, then after that you need to create a jar file. And after jar file, once your jar file is created, then what we need to do? We need to run one command. What is that command? The command is Hadoop command is Hadoop jar file path with jar file. Okay. Next one is class project name dot, I mean to say package name dot class and input path and output path. Okay. So here once your program is completed, you can create a jar file. That jar file you can place it into one path. What is package name for your program? The package name is Hadoop word count. Hadoop word count dot class name. So we have created three class names. Which class name we can give at the time of execution? In out of, suppose for example, for in your project we have 20 Java classes or 100 Java classes. Out of 100 Java classes, only one Java class contains main method, that is public static void main. In which class we have a public static void main, that is the main class. So in our program, this Java class contains a public static void main. That is nothing but this is our original main class. This is our main class. At the time of execution, we should give package name dot word count. Okay, that is clear. Now, what is file input format and file output format? File input format and output format should be your input path and output path. Okay. So here you need to mention input path and output path. In your input path, what is available? Your sample.txt is available. In output, what exactly it is available? After processing is completed, the output data is available in output path. Okay. And the next one, text, int writable and text. What is int writable and text? Suppose for example in MySQL, ID column you will give int is a data type, right? For string columns, suppose name, this you need to mention varchar. In Hive, we can give ID, for ID we can give int, for name we can give a string. This is the data type. In MapReduce program, okay, ID it is nothing but int writable. int writable. The data type is int writable, and for name we can use text. That is what int writable and text. What is path? Path, it is nothing but your input path and output path that is mentioned. That's why we can give a path library. Okay, remaining all are job client, job configuration, MapReduce job configuration. These are all related to MapReduce job, MapReduce job related configurations libraries. Okay, so just we need to mention all these things. Okay, whatever the classes here, mapper class and reducer class, whenever you have created a Java class, after it is executed, it was given one dot class file. That dot class file name we have mentioned here, word mapper dot class and word reducer dot class. Likewise, text dot class and int writable dot class. Okay, so this is the your main program. This is your main program. Now coming to mapper word map. See, we have a lot of errors in this program. We need to resolve it. Okay. So next, word mapper. In this word mapper, already we have discussed the for a B4. What happens in this B4? In this B4, first of all, the mapper phase, this entire line got divided. So what are the ways? We have two ways. Either we can use split. So based on the delimiter, we can split it, or we can use a string tokenizer, right? So I want to add for mapper phase related libraries. Okay. Now, so here you need to write a code. So here, if you can observe, we have a string tokenizer. See, we have a string tokenizer. See, by using string tokenizer, the line you can split it into number of tokens. That tokens, it is nothing but words. That tokens, it is nothing but words. The same thing, reducer. So no need to write any sort and shuffle code. So directly you can write a reducer phase. In this reducer phase, what exactly we are performing? We are performing a aggregates. So here also we can perform a sum operation. See, sum all the values, you need to sum of all the values based on the particular key. Based on the particular key. So this is the way you need to write a MapReduce program. Your program is completed, but still we don't have, we have a lot of errors in three programs. Why? Because of Eclipse doesn't know MapReduce libraries. Eclipse doesn't know MapReduce libraries. That's why we need to add. Hadoop libraries. What are the libraries we need to add? I will show you. We need to add Hadoop common jars. Hadoop common jars and Hadoop core jars. So whatever the jar files I have added in this project, the same jar files we need to add. So how to add? Go to build path, configure build path. Okay, so here if you can observe, add external jars. So here you need to click this. So you need to click add external jars. Okay, so in this user lib, go to Hadoop. Here we have a Hadoop common jars are available. Whatever the common jars are available, just simply okay, you can add it and okay. Once you can add these three jar files, few errors are removed. Okay. few errors are gone. Okay, see, few errors. Previously we have errors here, so few errors are removed, right? So now I want to add few more jar files. Okay. Okay. So this jar files. Again, build path. Configure build path. This time Hadoop 2.0 map reduce. So here we have a examples jar, test jar, and core jar. These three. Once these three jars also you can add, all the errors are removed. All errors are removed. Okay. So this is in word reducer. All errors are gone. In word mapper we have some few errors. Public class word mapper extends. Nested table cannot hide in the enclose. Okay, one more bracket, I think so. Now this error is gone. One, two, okay. Here, what is the issue? Word mapper. Oh, okay. Okay, done. So this issue is resolved and this issue also resolved. All the issues are resolved. Once all issues are resolved, what we need to do? We need to create a jar file. We need to create a jar file for your project. For your project, you need to create a, how to create a jar file. Just you can click the right click on your project, export. If you can click the export, we have a jar file. Okay, next. So home Cloudera downloads, we are saving our jar file name. So what is that? Hadoop word count example.jar. Okay, next and finish. Okay, warnings. Okay, see, this is warning. Warning is okay. Okay, warning is chalta, but error is you can 100% you can resolve it. Okay, this is completed. Now where exactly my jar file is available? Home Cloudera downloads. Where exactly I am available? Home Cloudera. Okay, so I want to go to downloads folder. How can I cd? What is a cd? Change directory. Okay, cd downloads ls-ltr, because the latest one. This is in red color. What is the meaning of red color, guys? This file doesn't have execution permissions. How we can change? By using chmod 777, and we can give this jar file. Enter. Now see ls-ltr. So this is also changed to I mean to say Hadoop word count example jar from red to green. That meaning it is having a execution permissions. This is completed. Now I want to create one directory. That input path should be HDFS directory. The output path should be a HDFS directory. Okay. Now I want to create one directory, Hadoop fs -mkdir / Hadoop word count example input. Okay. So whatever the data we have taken here, the same data I want to copy. This is my input data. Okay. Meanwhile, what I'm doing is I want to remove this. Okay, so this directory is created. Now cd dot vi, I want to create sample.txt. Why? Because of, oh sorry, vi sample word count input dot txt. Okay, why? Because of on top of HDFS we can't edit any file. Okay, so that's why I want to create a file with the data on top of LFS. What is the meaning of LFS? That is local file system. Now I want to copy this file into this directory. How can I copy? Hadoop fs -put, and I can copy, I can give this file name, and I can give this path name. This is input path. Okay, this is copied. Okay, now what I need to do, I want to execute this command. What is the command? Previously we have discussed Hadoop jar file name. Okay, and package name dot class input path and output path. Okay, so this is your jar file. So this is your jar file. Copy Hadoop jar. Where exactly our jar file is located? /home/cloudera/downloads. This is your jar file path and jar file name also. This is your jar file, right? This is done. Hadoop jar jar file path with jar file and package name. What is the package name? Your project name. I mean to say your project name dot file name, that is Hadoop word count. Hadoop word count. Because your project name and package name both are same. So in this program, which class having main class public static void main? That is word count. Okay, this is word count. Next, input path and output path. This is your input path. Copy. Okay, here what is the file name? Sample word count. I think no need to give. and output path you no need to create, guys. Output path you no need to create. Once the job is completed, output path it was created. Okay, no, only input path only you should create. Okay, enter. In Spark also we are going to follow the same steps. Venkat. Okay. Yes, Venkat. But almost the same. Almost the same. But there we need to create a Maven project. So what is the advantage of Maven project is in that Maven project we need to add dependencies. So here we are adding a jar files manually, right, for this program. But in our Spark project, Spark Maven project we are creating. In that Maven project, at the time of project created, you got one pom.xml file. In that pom.xml file, we need to add dependencies based on your requirement. Once you can add that dependencies, it was automatically create your jar files. No need to give them manually. That is a one step. The second step, 100%. So you can write your program, Spark program in Windows. Once it is completed, you should do a Maven build. In this compulsory process, because I don't know Java, in this compulsory, that is what I'm saying, Rohit. See, you should learn this only this program. That's it for MapReduce. When coming to your Spark, I should give the Scala first. Before Spark starts, I will give the Scala part. Then after that I can start the Spark. You no need to worry about, suppose if you don't know Java, nothing, no problem. I will give the Scala classes. Okay, Scala training classes I will provide. So you no need to write any MapReduce program with Java in our real-time scenario. No, nothing. No one is using MapReduce. Okay, you no need to bother about for that. But you should learn Spark with the Scala. Okay, that is compulsory. That is compulsory.
And sir, suppose that we are downloading Eclipse. So is that required to connect Eclipse with our Hadoop framework?
Yeah, obviously, right? You have completed your entire program you have written in your Windows, right? But where exactly you need to execute this Hadoop jar and this command, 100% you can execute on top of I mean to say 100% on top of your CloudX lab. Your CloudX lab. That is cluster. One cluster 100% it should be there. There only you can able to execute Hadoop programs. Okay.
So do we need to download virtual machines or use Cloudera
Nothing,
login?
nothing. Nothing, no need to. See, I will provide this credentials. I will provide this CloudX Lab credentials. You can
Okay.
download, you can download Eclipse, you can
Okay.
download Hadoop jar files. You need to write a program and you can add a Hadoop jars and you need to create a jar file for your program. That jar file you need to copy from Windows to your CloudX Lab. There you need to execute your Hadoop command. Okay,
Oh.
no need to
Oh.
download any virtual box machines, any cloud or nothing. Okay, for this I'm every 6 months only. This is only for my students. I'm giving this to my students only. Okay, yeah.
Oh.
Adi K, sir, do you teach PySpark? No, no, Adi. In this only Hadoop with Spark with Scala. That's it. Hadoop and Spark with Scala. No PySpark. If you need PySpark, no. As of now, I'm not giving any PySpark related things. See, guys, is it clear, Adi? Adi, it is clear because I know Python. Okay. Yeah, so I got your point, but as of now, so if you know Python, so you know Python and you can learn Scala also, right? Oracle also. Okay, no problem. Yeah. So guys, your program is successfully completed. In your command, what is your output path? This is your output path. Okay. So Hadoop fs -ls, you can go to this output folder. Here one file is created. Your output file is created. In that output file, you can see the output. How the word count example output should be. Okay, looks like. Okay, so this is your part file. Hadoop fs -cat, copy and paste. Okay, so here this is your data, right? This is your data. In this data, how many times currently it is in this B2 one currently and in this B4 one currently, right? So this is 2 times occurred. So for entire data got processed, currently it is occurred 2 times. See, currently it is coming 2 times. See, currently 2 times. And next one, Hadoop 1 time. So in the B4, we have I is occurred 2 times, YAM is occurred 2 times, and working is occurred 2 times. See, working is occurred 2 times. Okay, so this is AM. AM is occurred 2 times. I is occurred 3 times. In is occurred 3 times. This is for entire data set. This is for entire data set. This is a word count example. Is it clear, guys? Is it clear how to write a MapReduce program and how to execute a MapReduce program? It is clear, everyone? Amit, Rohit, Venkat, and
Yes.
Adi.
Yes.
Okay, cool. Okay, cool. So, guys, in our tomorrow's class, I will tell you we have few more components are I haven't explained you. That is nothing but secondary name node, fs image, and edit log. These 3 things. And what are the disadvantages in Hadoop 1.x and how to overcome disadvantages of Hadoop drawbacks of Hadoop 1.x, how we can overcome in the Hadoop 2.x architecture. Okay, tomorrow I will complete this. Once tomorrow class is completed, Sunday there is no class, guys. From Monday onwards, we have a actual. I will start the actual hands-on. That is First, I will start scoop. Once scoop is completed, I will start hive. Hive is completed HBase. HBase is completed pig. Pig is completed Scala. Scala is completed Spark. This is the flow. Okay. From Monday onwards, I will start the actual hands-on. My sincere request is, can you please respond to Durga's of team Amit, Venkat, and Adi? Okay. Thank you, guys. We'll meet tomorrow at the same time, 9 to 10 o'clock. Tomorrow, at any cost, I will complete this Hadoop architecture. Any questions, please let me know. Yeah, Venkat, tell me. Any questions?
Sir, will you cover Kafka and Cassandra in Spark?
Kafka 100% I will cover. Cassandra I will show. Just not that much deeper, but I will tell you what is Cassandra and other things. I will tell you. Okay.
Okay, sir.
Yeah. Any questions, Adi? Adi, do you have any questions? No. Okay. Amit and Rohit, any questions?
No, sir.
Okay, good. Okay, guys. We'll meet tomorrow. Thank you. Thank you so much.
Thank you, sir.
Yeah.